Hi, in this demonstration, I'm going to show you how using Cisco TrustSec, you can control access to resources running in public cloud environments like AWS. So for the purpose of this demonstration, I have got a EC2 instance running in a VPC in AWS right here. In particular, this is the one that we are referring to. I have got my identity service engine here with TrustSec policies set up. And I have got a Catalyst 3850 switch where I'm going to enforce my policies. That is right here. And there is a particular script that I'm using to orchestrate the information in the policy that I'll be running shortly and showing you what it exactly does. The reason why we are doing is, and the benefits of this approach is, number one, that IT today, because they don't have any visibility into what instances are running in public cloud environments, are not able to control these security policies for those, and that is a security risk. So with an approach like this, IT can easily and consistently manage security policies for instances running both on-premise as well as in the public cloud. And secondly, using TrustSec, these instances can actually, the security policies can actually be managed in terms of these simple group structures as opposed to in terms of IP addresses. Now, AWS actually has a construct of security groups as well. As you can see here, for this particular instance that is running, I have got a default security group that is associated with this. And if I look at the rules of the security group, I can see that although AWS does allow me to associate an instance with a security group and use that security group across multiple instances, the actual rules in the security group are still defined in terms of IP addresses, which can get pretty complicated once you get into larger environments. So with TrustSec, both the source as well as the destination the policies can be constructed in terms of a source group as well as destination group, and thereby you can actually make the policies even more simple. So let me show you what I'm exactly going to do as part of this demo. There's a small script that I've written which is going to do the following. It's first of all going to read the IP to the group mappings of the various instances running in AWS. For the groups that are the security groups that are defined in AWS associate these instances, it is going to create an equivalent security group in ICE, and it is also going to create an IP to group mapping in ICE for those IPs. Then as an administrator, I'm going to go configure my access policies from my employee to the AWS instance, and this policy is going to get provisioned in the network, and we're going to see how we are able to implement access control for this scenario. All right, so we talked about ICE, we talked about AWS instance. I also have got my employee user. This is my employee user. And this particular instance in AWS for these demonstration purposes is actually running a web server that is publicly accessible over the internet. So as I can see here, because my default policy for my internet access is permit all for the employee, I should be able to access this AWS instance. So yeah, the employee is able to access this AWS instance. I haven't defined any policies yet. So now let me go and run. So before we do that, let's actually look at our policy matrix here in TrustSec. There is no information or knowledge about any AWS instances running today or AWS groups. I can actually go to components and see that in ICE, currently, these are the groups that are defined. So let me go ahead and run this script, which AWS. So let's see what the script is doing. It is looking at what the AWS instance is running. It is identifying the IP to the AWS group mapping, what the group names are, and it is creating the equivalent SGT groups in ICE for these, as well as creating the IP to SGT mappings. So if we refresh this ICE UI, you'll be able to see I have actually in my AWS environment two security groups, AWS default and AWS launch wizard. They have been created. And I should be able to see that um, in the policy matrix as well. I should be able to go ahead and see what the policies are. Okay. So by default, my policy for all cells that is not defined is a permit policy. So for my employee to AWS default, I believe with that the EC2 instance is actually so the EC2 instance is default policy. This is a default permit, so as the end user should still be able to access this particular web server. But now I can very easily go ahead and define a deny policy. And let me make sure that this has actually been propagated down to the switch. Actually, I need to do a policy push. And let's just refresh the policy. See that the policy being downloaded successfully. So for employee to AWS default, now it's a deny policy. And let me show you that we are actually not able to access this resource anymore. There you go. The employee is denied access to this AWS instance through a very simple policy model using TrustSec. And the script should also be available on GitHub. I'll post the link very soon. But just a simple proof concept to show how you can actually control access to you can control access policies for your instances in public cloud using TrustSec.